So today we're going to be looking at composite transformations. That means a couple of transformations in a row. We're going to be performing a sequence of transformations. So that's like a composite transformation. You need to know it, like we've said a few times, because transformations create congruent relationships. And congruent is the key thing to understand about geometry. We're going to be doing a lot with congruent. And you know you can do it when you can correctly transform a figure, no matter how it's given to you. So a composite transformation, like we said, is a series of transformations containing two or more transformations in one graph. You do the first one, you draw where it's supposed to go, and then use that for the second one. A big thing to kind of note here is that the order matters. You've got to do it in the order that it tells you to. If it says reflect and then translate, you have to reflect before you translate. So you do them in whatever order it tells you to. So you could have everything, reflections, rotations, stretches, translations, all that stuff. You could have it all in one problem. So how do you know when to do a composite transformation? Number one, it's going to tell you a couple of things. So it might say two different things. Rotate 180, then slide. The second is if they give you a rule. They give you a rule that looks complicated. This is more complicated than any of the rules that we did so far. So the key to this, though, is that whenever you see plus or minus numbers at the back, that tells you a translation, because translations are always the add or subtract part. Yeah. So slide left 2, that's why there's the -2. Up 1, that's why there's a +1. That comes from the translation. The rotate 180, you can see that there also, because rotate 180, that rule is that it goes to -x, -y. So you can see the -x, -y. That's the rotation. And then you can see the -2 + 1, that's the translation. So translations are always the add or subtract step. Rotations and reflections always have the multiplication going on. Sometimes they switch places. X and Y might switch places. Sometimes they change signs with the negatives. That's what you're looking for to figure out what it is. And then the last way, this is a composite symbol right there, that little circle. You'll see it again in Algebra 2. You read it right to left. So you do this one first. And this one second. So you would rotate 180 degrees first, then translate -2, 1. So here we've got a sequence. We're going to reflect over the y-axis, and then we'll translate. So first, let's reflect over the y-axis. So right now, B is 2 spaces to the right. When you reflect over the y-axis, that line is going to be 2 spaces to the left. And you call it B prime, because that's after you've moved it. Do the same thing with O. Reflect it over, 2 spaces, 2 spaces. Call it O prime, because that's the after you moved it. It's the image. So now you take the pre-image X, it's 5 to the right. So when you reflect it over, it goes 5 to the left. And call it X prime. So there's our first step. Now you can translate it. 3, 4. So remember the first number tells you right or left. Positive is right. 4 tells you up and down. The second number, positive, is up. So we're going to take each point and go right 3, up 4. 1, 2, 3. 1, 2, 3, 4. Now, since that's the second time we move B, you call it B with 2 primes, B double prime. O, same thing, 3 to the right, up 4. And call it O double prime. X, and call it X double prime. Now, for your rule, you got to write down what each one kind of does. So the reflection over the y-axis, that goes to negative x comma y. That's the rule from our reflection lesson for over the y-axis. And then the translate 3, 4 means that you're then adding 3 and adding 4. So when you put that together, goes to negative x plus 3, comma y plus 4. Then for your notation, you just got to remember that you kind of write it backwards. Remember, you read it right to left. So the first thing you do goes after the circle. The second thing you do goes before the little circle. So it's a reflection over the y-axis first, and then a translation by 3, 4. So for this one, we're going to be rotate 90 degrees clockwise, which you can do with tracing paper or whatever. Hold it still at the origin, and after you trace it, just write where it moves to. Or you can apply the rule, which we're going to need in a minute anyway. XY goes to Y negative X. So this point B right there, it starts at 2, 3. Applying that rule means that it's going to go to 3, negative 2. 3, negative 2. which makes sense because it's going 90 degrees clockwise. Should be going down that way. So that's B prime. We can do the same thing with X, which is starting out at 5, -2. The rule says that X and Y change places, and X is going to go from 5 to a -5. So -2, -5. And you can do the same thing with the O. Starts out at 2, -2. If you apply the rule, they switch places, so that's going to -2, and then you change the sign. X changes signs to -2. Or it might have been easier if you just traced it out and visually saw where it went to. But it makes sense where it is. Then the second step says now we're going to translate the figure -4, 5, which means 4 left and up 5. So for each point, count it out. 4 left, up 5. That's O double prime. That's X double prime. 1, 2, 3, 4. 1, 2, 3, 4, 5. B double prime. So we can put that together with our rule. XY goes to Y, and then we got the -4. So put that all together. And then -X plus 5. Our notation, remember the first thing goes after the circle, so our rotate 90 degrees. And since it was clockwise, remember that was actually a negative. It's a little thing from the notes 1.4. And then the translate. So that's your notation. So here we're going to translate first, then reflect over the y-axis. To translate -2, 6, that means left and down. Now, to be careful, we've got a marking here at 4 and at 8, which means all of these are counting by 2s. You're going to see that a lot where the scale changes on your graphs, so you got to be careful. So left 2 and down 6. 2, 4, 6. That's A prime. B, left 2, down 6. 2, 4, 6. And then same thing with C. Left 2, down 2, 4, 6. Now we're going to reflect it over the x-axis, so over that line. So since it's 1 unit below, it's going to reflect to 1 unit above. C is down 1, 2, 3, 4 units, 4 of these lines. So 1, 2, 3, 4. Same up above. Three lines down below, so 3 lines up above. So now we're going to do the same thing, but we're going to do opposite order. We're going to reflect first, and then we'll translate it. So if we reflect first, A is going to stay put because it's on the line. C is going to move, instead of 1 line below, it's going to be 1 line above. And then B, 2 lines above, is going to reflect 2 lines below. So there's your reflection. And now we're going to translate -2, -6. So left 2, down 6. Left 2, down 2, 4, 6. 2, 2, 4, 6. Left 2, down 2, 4, 6. So if you did them in one order, you end up over here with the blue triangle. If you did the other order, you end up here in the green triangle. Just to show you, like we wrote earlier, order matters. That's it. Order matters. If you reflect before you translate or translate before you reflect, you're going to get different places. So you have to follow the rules, the order that they're given to you. We're going to reflect over the line y equals 2. So draw in that line, y equals 2. The reflections are pretty easy when they're drawn out. C is going to stay put. B, move 2 spaces down below. And A, you just got to count it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got a question down here, though. What, or can you find a composite transformation that would be the exact same? So rather than saying reflect over y equals 2, can we do something else and end up in the same spot? Maybe 2 steps. So for me, what comes to mind is if we reflect over that line instead. If we reflect over the x-axis, and draw where that would go. That's where B ends up. And C. And then A is right down there. So if we did a different reflection, it's just down here instead. And then to move it where it needs to go, just has to move up 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. Move it up 4 spaces. So then translate up 4. So that would just be the vector 0, 4. You can come up with a whole bunch of other ones too. You can reflect over pretty much any line you wanted to and make it end up there. So for this one, it just gives us the rule, which is actually kind of easy. You just have to write out what the coordinates are. A is at 2, 1. So when we apply the rule, we go 2 minus x. X was 2. So it's 2 minus 2 is 0. And then y stays the same, so 1. And that would be a prime. We'll draw it when we're all done. B, so over here it's 6, 0. Apply the rule 2 minus x, comma y, so 2 minus 6. 2 minus 6 is negative 4. And the y stays the same, so y stays 0. That's B prime. And then last, we'll take C, which is 4, negative 5. So x is 4, so 2 minus 4 is negative 2. And then y stays the same, that's negative 5. That'd be C prime. And you can plot all those points out. So 0, 1, negative 4, 0, and then negative 2, 5, negative 2, negative 5. That's C prime. And just by looking at that, you could see it was reflected over, which makes sense because of the negative x, y. And then there's also some translating going on with it too. Or maybe you see that it could have just been translated over that line right there, or reflected over that line.